All right, mathletes, here's 3.6 real zeros of a polynomial. Big theorem we'll be working with here is if x minus c is a factor of a polynomial function, f, if and only if f at c is equal to 0. In other words, if you find a 0 of f, then you also know one of its factors and vice versa. All right, so let's see on how this works out. Okay, so if x equals 4 is a 0, that implies that x minus 4 must be a factor. Okay, so if f of x is equal to that cubic, I want to write that whole piece here in factored form. Well, to do so, I want to use synthetic division. So I remember from synthetic division that I'm going to let this value be 4 here because our general form is x minus c. So for synthetic division, we just take the opposite of that. So we have 4, and we're going to divide it by, I'll have a coefficient 1 there, coefficient -5 there, 2 there, and an 8. 1 dropping down is 1, times 4 is 4, and I get -1. Multiplying it across, I get -4, -2, and then an 8, and I get a remainder of 0, which tells me, yes, it is verified that it's a factored form. But what's valuable is what's left over. So then if I have that factored form, I know that f of x can be written as a factor of x minus 4, and from this, I get x squared minus x minus 2. Well, by inspection, I can factor this second quadratic, so I get x minus 4 times, this is going to be x minus 2 times x plus 1, factoring that quadratic above, and I can see I have now written my cubic in factored form. By just knowing one of them, it helps it break it down, and then we can use our previous established tools to factor a quadratic. Let's look at example number 2. If x plus 4 is a factor of that degree 6 function, and determine if it is a factor, we just have to do our synthetic division again. So from our general form, I'm going to use -4, like the opposite of that, and I'm going to divide it by. Remember to put placeholders where we don't have terms. So x to the 6th, no x to the 5th, x to the 4th, no x to the 3rd, x to the 2nd, no x, and then my constant term. So as I come through and do this, I drop down my 1, get -4, add those up, I get -4, times -4, I get 16, that goes to 0, 0, 0, 0, 1, 1 times -4 is -4, add those up, -4, I get 16, and I get a remainder 0. Therefore, I know it's a factor. So yes, x plus 4 is a factor of f of x. It's because I got a remainder 0. I divide something by its whole piece, and I get a remainder 0. It's a factor. Example 3. So using the factor to determine whether x minus c is a factor of f. If it is, write f in factored form. Okay, so if c equals 1, that gives rise to the factor x minus 1. So using synthetic division, I have a 1 there. I divide out by coefficient of 1, -4, 9, -6. Drop this down and I get 1. And then I get a 1 here, -3, -3, 6, 6, remainder of 0. So there, I know it is a factor. So to write it in factored form, I can use this piece here, and I know that x minus 1 is a factor, times x squared minus 3x plus 6 equals f of x. Okay, X squared minus 3x plus 6 cannot be factored down anymore. I can't find things that multiply to 6 and add to 3 or negative 3. It's not going to work out, so I can just leave that in simplest factored form there. And B, to see if c minus 4 is a factor of that f of x. So I'm going to go ahead and do, that means x plus 4 would be a factor. So negative 4, my long divisions, or synthetic division. And x to the fourth has a value of 1. No x to the third. X to the second is 1. Then negative 3, and then 1. So I get 1, negative 4, negative 4, 16, that's 17, I believe this is negative 68, and I get negative 71. It's not equal to 0, so x plus 4 is not a factor. All right, so that can be useful in testing if something's a factor. All right, so some vocabulary here. The number of real zeros, a polynomial function of degree n, has at most n real zeros. Okay, the rational zeros theorem, let f be a polynomial function of degree 1 or higher of the form they're given, where each coefficient is an integer. If p divided by q in lowest terms is a rational zero of f, then p must be a factor of AO and q must be a factor of AN. So notice that p is coming from AO, that's our numerator, and our denominator, q, is a factor of AN, our leading coefficient of our power function. Okay, so that can help us get a long list of possible factors, but it can help us generate possible solutions if we know and look at a graph here. So let's see how we can use this. Okay, so find the real zeros of f of x equals 2x cubed minus 5x squared minus 4x plus 12. Determine the most real zeros. Well, this is degree 3, so at most we can have 3 real zeros. So determine the possible rational zeros. So from before, I know that p is the factors of 12. So the factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. For our q, our denominator, that comes from this piece. Okay, so factors of 2 are going to be plus and minus 1 and plus and minus 2. All right, so if I graph this function, so before I graph this, I want to make sure I look at these possible solutions. So I know it's p over q. So we don't want to do too many repeats here. So I just kind of start with my first one. And so this could be plus or minus 1. That it's p over this q, or it can be plus or minus 1/2. Okay, then I go to the 2. Now it's 2 over 1, so it'd be plus or minus 2, and 2 over 2 is 1. That's repeated. I'm not going to rewrite that one out again. And then 3, so then I have plus or minus 3, and then I could have 3 over 2, plus or minus 3 over 2. Then I have 4, plus or minus 4, and then 4 over 2 is 2, so I don't have to rewrite that. 6, so I get plus or minus 6. 6 over 2 is the same thing as 3, and I already got 3, so I don't need to write that one. And then 12, so I get plus or minus 12. And 12 divided by 2 is going to be my 6, so I don't need to repeat these. So these are possible roots here. So I go ahead and put in my calculator and graph it. I get a graph something like this. I put in my y equals. I do 2x cubed minus 5x squared minus 4x plus 12. And do a standard window, zoom 6. And I can see here. So a possible 0 to tests, it looks like right here, I potentially have a 0 at x equals 2. Okay, and that was one of the possibilities that I came up using that theorem. So if I want to go ahead and test that, okay, I'm going to use synthetic division. So 0 at x equals 2 gives a factor of x minus 2. Okay, so synthetic division, I use a 2 there. And my coefficients, I have 2, -5, -4, and 12. 2 goes into here, drops it down. I get 4, -1, and I get -2, -6, -12, and sure enough, I get my remainder of 0, and so that is a factor. So I know that, and then from there, I get that f of x can be written as x minus 2 times 2x squared minus x minus 6. Now that it's a quadratic, I can try and factor in my typical way. So I get -12. Things that multiply to -12 that add to -1. Well, that is going to be -4 and a +3. So I can write this as 2x squared minus 4x plus 3x minus 6. And this is going to be factor out a 2 and an x. And I have an x minus 2. And then factor out a 3. And I get an x minus 2. So then I can factor, and this is all, and this is just dropping down. So I have x minus 2 here. So then my final factor is x minus 2, x minus 2 there, and I get a 2x plus 3. Okay? And so that is my factored form of f of x. Last example. Find the real zeros of f of x equals 4x to the fourth plus 15x squared minus 4. So my p is -4. So in there. My q and my q is equal to 4. So then I list out my possible factors of -4. So that's plus or minus 1, plus or minus 2, plus or minus 4. Same thing is going to be for 4. So then I do p divided by q. And my possibilities are 1 divided by 1, I get plus or minus 1. 1 divided by 2, so I get plus or minus 1 over 2. And 1 divided by 4, I get plus or minus 1/4. And then 2 over 1, I get plus or minus 2. 2 over 2 is 1. That's a repeat. I don't need that. And 2 over 4 is a repeat of 1/2. And then I get plus or minus 4. 4 over 1, 4 over 2 is 2, that's a repeat, and then 4 over 4 is 1, and that's a repeat as well. So these are my possibilities. Go ahead and put in my graphing calculator. It's going to look something like this. Okay, and it looks like right in between, I potentially have a 0 at the 1/2. Okay, so let's find that, and potentially at -1/2. Looks like it's right in between, so let's go ahead and test those. So if we do our synthetic division, I'm going to have 4, 0, 15, 0, and -4. And we're doing it by 1/2. Okay, I drop down 4, and I get 2. Drop that down, and I get 1, that's 16, that is 8, that drop that down, multiply by 1/2, that's 4, and I get a remainder 0, so that was a factor. Well, I know that this gives rise to the factor of x minus 1/2, and a factor of a solution or a root at 1/2, x-intercept. So the other one is if it was -1/2, so that would be x plus 1/2. So I can divide it through on this function. And so I do this by negative 1/2. And I see that 4 times negative 1/2 is going to be negative, well, drop this down first and I get negative 2. And I add this together and I get 0. And multiply by that and I get 0. 16 multiplied by negative 1/2 is negative 8. And sure enough, I get my remainder of 0. So what am I left with? So I know that this f of x can be written as x minus 1/2, x plus 1/2, and then I have 4x from that squared, no linear term, but plus 16. Okay. This cannot be factored anymore. So we're just going to leave it there, and we have our factors of f of x. Go ahead, highlight any questions you have in the notes, and I'll see you in class tomorrow.